Hello. Today I want to talk about CMake and a little bit about how it works and why it works, and demo some setups for it, so that to get the word out, because CMake is your friend and it's good for you. So let's start with the simple case. This repository and the repository for the animations that are going to pop up here in a second are all available. They should be linked under the video. Yeah, and I didn't even start with a clean directory, so let's fix that. Okay, so here we have a makefile and a couple of source files. We have main.cpp, we have secondary.cpp. Main.cpp includes the header file, secondary.hpp, as does the secondary source file. The code itself here is not interesting at all. We're just calling the secondary foo function inside main and returning 0. This is strictly about being able to compile stuff. This is not about any type of good C++ practice or anything like that. So this is just worrying about the compile things. So looking at our makefile, we say that some program is dependent on these three source files. So if any of these three source files get updated, then we're going to run this command line in order to be able to produce some program. So this is just g++ main.cpp secondary.cpp with the flag to create the output as some program. And if we run that, we see that it creates some program, and we can run some program, and it says secondary foo called. And yeah, very simple. The thing here is that no matter what we touch, it will rebuild all of the source files every time. So no matter what we do, we're paying the full price for the compilation of the entire program, no matter what we change. So that's not great. So moving on to the second demo, this is a slightly more complicated makefile. This makefile, which is over a page long, has some compile flags in it, so it's a little bit more functional. But again, it says that the source code is in main.cpp and secondary.cpp. It has a bunch of magical symbols from Make itself, and it says how to build the file. So this builds the same exact program. This is the same exact source code. And if we run make, we can see that it does 3 invocations. So it does a g++ on main.cpp to create main.o. It does another invocation of g++ on secondary.cpp to create secondary.o. And then it will combine those 2.o files into some program. And if we see here in the directory, we have .o files for main and for secondary. And then we also have this .d file, which says what the dependencies are for our object files. And these are what tell it that secondary.hpp is involved. So if we touch secondary.hpp here, and then run make, we will see that it recompiles the entire thing. But if we change just secondary CPP and we run make again, now it only does 2 things. So it skipped recreating the main object because the main object didn't change because none of its dependencies have been updated, which are main.cpp and secondary.hpp. Only secondary.cpp has a newer date. So it does the minimum amount of work to create the program. And that's really cool. Makefiles are really great. Make is amazing technology. As long as you carefully specify all the dependencies and everything is correct. Now, I don't particularly like the syntax of makefile. There's a lot of arcane symbols in here. If you don't understand what's going on, you're basically just toast. You could ask the AI to explain it to you, but like you're just in crazy town, right? So let's move on to CMake. So here is our CMake. We have things moved into a source directory now. So main.cpp and secondary.cpp and the header file all live in this source directory, and we added this new file at the root called cmakelists.txt. Cmakelists.txt is a lot shorter. So the makefile was 30 or so lines. This is only 17. And yeah, we have some white space and we have some comments, right? So there's very few lines of things that actually matter in here. So we have the CMake minimum version, which is just a boilerplate to say which version of CMake this CMake lists works with. And then we declare that what our project name is, and that we're using the CXX style, which is all C++. And then we're saying that we use C++ 11 and that we require that version to be available. And then we say that we're creating an executable called some program, and then these are the 2 source files needed for it. And that's it. So if we make a build directory and we go into there and we generate the CMake files, and then we run the make CMake style, then we can see that we have some program. We run some program, and it again gives us our output from our very simple C++ program. That's pretty cool, because that's fewer lines of things that we have to maintain, and there's not as much arcane language in here. Like, there's no special symbols. I mean, there's a couple parentheses, but for the most part, this is fairly understandable and extensible. Like, if we need to add more source files, we just add them in the add executable section, and other than that, the build never changes. So moving on, if we go to library-based CMake, so this looks a little bit different. So now we have a subdirectory called secondary that we have moved our secondary C and header file into, and this is a step on the way of having a more sane build layout. This will actually build a library that has secondary in it that will then link in with main.cpp. When we do that, like, it doesn't make sense for this small of a project, but if there were multiple libraries involved and there was more files that made up those libraries, then it would make a lot more sense. But I'm trying to keep this demo small enough to be digestible. So if we make a build directory, and then we generate the CMake build system, and then we build using that system. Is that the right? Yeah, that's the right thing. Then we can see we again get some program. We also get this new file, this libsum.a. This has the secondary C++ file in it, and things are starting to get interesting here. So we can run some program, and it still does the same thing it always does. And if we touch the secondary.c++ file, then we can run CMake, and we can give it verbose to tell us what it's doing a little bit better. So here we will see that it rebuilt secondary.cpp, and it made the secondary.o file, and then it will create this static library, libsum.a, and then down here it doesn't recompile the main.cpp, but it does combine the main.cpp object file with libsum.a to recreate the file. And as things get bigger and more complicated with more libraries, then this ends up saving time, because you don't have to look at all the individual object files. Your library can have multiple object files in it, and it will only rebuild the library if any of the library sources got updated. So now we start getting a little bit more interesting, and no animations this time, because this is adding dependencies to CMake. So we're using a script called cpm.cmake, and this is just a community provided file. So you download this, you put it in your repository, and it adds the magic to CMake so that you can declare dependencies, and they will be automatically downloaded and compiled as part of your project, which is really handy because nobody likes having to install a bunch of libraries before they can compile your program. So here we've updated the standard for C++ to use C++ 17, and then we're using CLI 11 and speedlog. These are sourced from GitHub, which is those little GH : prefix here, and they allow us to do some fun things with our program. So let's look at how main changed. So if we look at main.cpp, so we're using the CLI library. We've got the includes for the CLI and speedlog up here, as well as our normal secondary.hpp. And we say that, okay, we want our command to take a debug flag. And if we have a debug flag, then we're going to change the logging level in the library to be the debug level of logs, not the info level of logs. So we do that based on the command lines argument parsing that CLI 11 is doing for us. And then we'll set the debug level, or set the level for the logging, and then we'll log a couple messages. We'll log starting up, and we'll also log debug mode active. And the debug mode active is only if we have debug, will only show up if we have the debug mode enabled. So what that looks like is if we go in here and we generate the CMake build, and then we build our program, build parallel. Parallel makes it build faster by running multiple compilations at the same time. So now we have our some program again, and some program. So we have a new log message called starting up, but now we can also do some program -d, and we will get more information. We'll get a debug log, and the debug log has a little highlighted debug in a different color, and it has our debug message in it. So with very little effort, we've used some dependencies, some external libraries in our C++ program, and the system doesn't have to have those installed. The code base itself specifies that it needs them, and it will download and compile them as part of the project. Super, super great. Moving on, the last thing is CMake with tests. And for this one, I have split this up into a little bit more of a refactored type code base. So again, we're using CPM, and we're still using the library form of the actual CMake build itself. And we have this new directory at the root called tests. And here we have some test source code that is, in theory, running our program and running tests against it to make sure that reality is good. And I'm going to show this test, but I want to stress that this is not a good test. This is just a test to show that the test framework is working. This is not actually testing anything about our code. It is running something about our code, but we're not actually doing any asserts that have anything to do with our code. So without further ado, this is the test that we're running. So we're calling secondary foo, and then we're saying that we're going to crash if 1 is not equal to 1. 1 is always equal to 1. This test will never crash unless secondary foo crashes internally, which is not likely to happen, especially with how we've written it, because we're just doing a cout. So that's always going to be fine, but this is showing what's necessary to pull your code into the test suite and be able to run the test. Like, if you're not into testing, I highly encourage you to get into testing. It will save you a lot of time. So beyond that, let's look at the CMake lists.txt in the tests directory. So this is using some file globbing magic, which will grab all the C++ files in the tests directory as test sources, and then it will use that test sources variable to say this is what is as part of our test suite. It will then link the libraries. We probably didn't need catch2 and speedlog in here. I just wanted to show that the libraries were accessible. I think it would work without them because we're not using either of those libraries in secondary itself. Then we add the include directories so that we can get to the secondary header file. And then we're using some CMake test integration stuff, which we'll show off in a second here when we get an actual build. So, and and this is the root directory CMake lists.txt. So this is much the same as the one with dependencies. However, we've now added Catch 2, which is the test framework we're using. You could easily use Google Test or some other test framework. We happen to be using Catch 2. And then we need to add this in order for the compile stuff to work. Enable testing enables the test integration stuff in CMake. And other than that, most of this is the same. So this add subdirectory tests, this is what actually goes into the tests directory, grabs its CMake lists, and basically pastes it where this add subdirectory line is, but has everything referenced as if it was in the subdirectory. So if we go in here and we make their build, and then we generate the CMake build system, and then we build everything, and there's a lot more to build this time because Catch 2 is a little larger. So build Catch 2, builds the library, builds our executable, and builds the test. So now if we run ctest, it will run our test executables, and it will say that everything passed. We can also run the test executable directly, and we can also run our program, and we still support -D. So yeah, that's about it. If you have any questions, let me know. But this has been an exceedingly quick whirlwind tour of CMake with demos and hopefully enough information to get you started. Have a great day.